All right, everybody, this is video number 2 of the 2.5 notes. All right, so the first thing we have here is talking about limits at infinity. And we've got a couple scenarios here. It says if R is a positive rational number and C is any real number, then the limit as x approaches infinity of C over x to the R equals 0. The limit as x approaches negative infinity of C over x to the R is also equal to 0. So what you want to think about is C is some real number, some constant value. If we're talking about x to the R and x is approaching infinity, that means we're saying infinity to some power. So you're basically taking a constant number, a relatively small number, and dividing it by infinity. In that case, whether that infinity is positive or negative, you're going to get closer and closer to 0. So the limit as x approaches infinity in that case is going to be 0. So if we took a look at this example and how do we apply that idea, we want to find the limit as x approaches infinity of 4 plus 3 over x. Now with limits, we can apply properties to split this up as the limit as x approaches infinity of 4 plus the limit as x approaches infinity of 3 over x. Now, the limit of a constant is the constant. So it doesn't matter what x is approaching here. The constant value is 4, so we're going to get 4 plus. Now here, the limit as x approaches infinity, well, if I take 3 and divide it by infinity, that's where we're going to apply this idea right here. 3 would be our constant. We have infinity on the bottom, so we get 0. So the limit as x approaches infinity of 4 plus 3 over x is simply going to be 4. All right, as if you have any questions on that, you could definitely ask your teacher. All right, let's get into some of the other examples. All right, we want to say for each function, we want to identify all of the asymptotes. We also want to find the limits to infinity and negative infinity using horizontal asymptotes or rates of growth. All right, so if we take a look at example 3, we have what would be considered a rational function. So to identify those vertical asymptotes, we're going to want to factor the numerator and denominator, which the numerator is already factored. The denominator is a difference of squares. So this is going to be 3 plus x and 3 minus x. All right, at that point, you're looking for factors in the numerator that are also in the denominator, which we don't have any of those. So anywhere the denominator is 0 is going to be a vertical asymptote. So in this case, we're going to have vertical asymptotes when x is equal to negative 3 and x is equal to positive 3, because those are the values that will make the denominator 0. Now for our horizontal asymptotes, so for the horizontal asymptotes, we can, because they're both polynomial functions, we can think of them having the degree on top being the same as the degree on the bottom. So for that to work, I've got x squared on the bottom, but only x to the first power on top. So I'm just going to add 0x squared on top. That means that the horizontal asymptote is going to happen at y equals 0 divided by negative 1, okay, because negative x squared really should be the lead term. So 0 divided by negative 1, which is 0. All right, that takes care of identifying all of the asymptotes for that function. Now, we were also asked to find the limit as x approaches positive infinity of f of x and the limit as x approaches negative infinity of f of x. So, I mean, what I would do to help in that situation is I would sketch a graph All right, we're going to use the asymptotes to help us. So we said that there are vertical asymptotes at -3 and also at +3. We have horizontal asymptotes at y equals 0. All right. Now, at that point, you'd want to pick some points on other sides of the asymptote. So, -3, I could plug in -4. So if we were to plug in -4 up top, you've got -8 in the numerator. -4 squared would be 16, so 9 minus 16 would be -7. So -8 over -7 is actually +8 over 7, which is just over 1. So I'm going to have this happening on the left side. A simple value to plug in between here would be like 0. So if we plugged in 0, 2 times 0 is 0. As long as the denominator is not 0, we'll get 0. 9 minus 0 is 9, so 0 divided by 9 is 0. So you have a point on the x at 0, 0. If we plugged in -1, then the numerator becomes -2. -1 squared is 1. 9 minus 1 is 8. So -2 over 8 is -1/4. So that would give me a point about here. If we plugged in +1, then we get 2 on top, 8 on the bottom. So 2 over 8 is 1/4. So it's going to look like this, which if you were to continue to plug in points, you would see that the graph will do something like this. And if we plugged in +4, 2 times 4 is 8 on top. 4 squared is 16, so 9 minus 16 is -7. So +4 would give you -8 over 7, which would be down here. And your graph would have a shape similar to this. So if we wanted to talk about the limit as x is approaching infinity, we're looking at the graph as it goes to the right forever, and we are approaching 0. And the limit as x approaches -infinity, we would be going to the left, and we would be approaching 0 as well. Okay. It's important that you guys recognize that those are the horizontal asymptotes. Okay. Limits to infinity are usually determined by those horizontal asymptotes. All right, if we took a look at example 4. So example 4, kind of same idea from the beginning. We cannot factor the numerator or the denominator. So when we're looking for the vertical asymptotes, it's already factored. We just need to know when does 3x minus 1 equal 0. Well, that's going to happen when x is equal to 1/3. For the horizontal asymptote, you have the degree on top as 2, the degree on bottom as 1. So when the degree on top is larger than the degree on the bottom, that means there is no horizontal asymptote or none. All right, and what ends up happening is when there's no horizontal asymptote, typically there's going to be a slant asymptote. And that's when the degree on top is exactly 1 degree larger than the degree on the bottom. So you can find the slant asymptote by using division. All right, and the quickest way in this case is actually going to be to do synthetic division. Not synthetic division. We have to do long division in this particular case. So in using long division, we're going to have 3x minus 1 dividing into -2x squared plus 0x plus 3. All right, and then we want to know how many times does 3 go into -2/3? Or the way I always talk about it is, what are you going to multiply 3 by to get -2? All right, and the only way to multiply 3 to get -2 is to multiply by -2/3. So -2/3 times 3x is going to become -2x. -2/3 times -1 becomes +2/3 x. Excuse me. I forgot the x up top there because that's x squared. So at that point, you would subtract those values, which means these signs are going to change. So that becomes plus, that becomes minus. Those cancel. We've got negative 2/3 x plus 3. And then again, it's what do we multiply 3 by to get negative 2/3? And in that case, we are going to multiply, let's see. So we need to get negative 2/3. What is that going to be? Negative 2/9. Okay. So we've got negative 2/9. That's going to end up with negative 2/3 x plus 2/9. All right, you're subtracting those values, so that becomes plus, that becomes minus. To get it to combine here, we would need a common denominator, so add a 9, so this is going to be 9 times 3, so 27 minus 2, which is going to be 27/9. That's going to be the remainder, which is not all that important to us. So we have a slant asymptote at y equals negative 2/3 x minus 2/9. All right. Now, this obviously becomes a much tougher situation to graph. So I'm just going to sketch a quick graph in terms of what this is going to look like. So if we go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. All right, and for our purposes, we can scale the graph however we want. So I'm going to make that 1, which makes that 2. And the benefit of that is now I have each one of my tick marks being worth 1/3. All right, so now when I go to, plot some of these points, if I have a vertical asymptote of 1/3, I'm going to go to the right 1 mark and put my asymptote. All right, I've got y equals negative 2/3 x minus 2/9. So negative 2/9 is going to be, let's see, it's going to be about right here. All right, and then if my slope is negative 2/3, I'm going down, so that would be 1/3, 2/3, okay, over 1, which would put me over here. And you have this slant asymptote that's going to look like that. All right, and I get this